All right, welcome everybody to video 1.4. We're going to be talking about rounding. I'm going to imagine this is not something that's new to most of you. This is probably a topic that you've heard about before, that you know something about. Um, but we're going to talk about it, and we'll talk about some examples and some ideas and some models that might be new to you. So hopefully this is going to be worth your time. So what do we mean by rounding? Well, rounding is an approximation that we do with a number to make it easier to talk about. It might be doing it to make it easier to calculate with. A whole bunch of reasons why we might want to round a number. It's worth having a conversation with students about this process of rounding, because even if they've not seen rounding in this place value form that we're going to be talking about, it's a process that we use all the time. If you ask a student what their age is, then they might say that they're 7 years old, and they're not giving months, weeks, days, hours, minutes, seconds. They're not using as the smallest possible unit of time. They're rounding to a year. They're saying, "Well, I'm 7 years old," and it's understood that today is not their seventh birthday. Um, you might hear a student also say, "Well, I'm 7, but I'm almost 8." And so what they're saying is that if you were to round to the nearest year, then it would round up to 8 years old. I'm not 8 yet. I haven't gotten to that birthday, so I can't call myself 8. But if we were to round that next year, the closest year would be 8. And you might get a student who does give their age in years and months, and they might say something like, "Well, I'm 7 years and 10 months old." And so now we're rounding the weeks, the days, the hours, et cetera, et cetera, et cetera. So even if students haven't seen this as a formalized mathematical process, this is an idea that we talk about all the time. Anytime students are doing some sort of approximation, and it doesn't have to be age, it could be the number of people in the United States, it could be the weight of the Earth, any of these sorts of things. It's being rounded to some value, and it's worth like looking at something that has a large value that has a lot of zeros to it, and asking, like, do we think this is the exact value, or do you think this is being approximated? And that's a good launching point for this conversation about rounding. So let's look at a couple of examples about rounding. So let's say that we have this number, say 72. So we're going to round 72 to the nearest 10. And so we are going to be looking at this tens place, and we're going to recognize that this is between 70 and 80. And so this tens place is going to let us know the smallest value, the smallest place value that's going to be non-zero. So we're going to have place values smaller than the tens. We're sort of a ones place, but everything below it's going to be a zero. And so we know that this 7 in the tens place, 7 and 8. So now this 72 is between 70 and 80. And we want to look at the distance from here to here. And so this is a distance of 8, and this is a distance of 2. And so the closest value would be this 70. The 72 is closer to the 70 than it is the 80. We could also round the 72 to the nearest 100. And so we would have to think about, well, what's in the hundreds place? Well, it's a 0. And so we know that we're going to be rounding between 0 and 100. And so this is going to be a lot closer. This is 28 to 100, and it's 72 to 0. But when we talk about it, we have to be talking about it in regards to a specific place value, and we're going to think about which one is closest to using that place value as the distance, as the unit of measurement that we're going to be using for this problem. So we could also talk about 72 being rounded to the nearest 1. But since the ones place is already the smallest non-zero place value, there's nowhere for it to round. 72 is already a distance of 0 from 72, so there's nowhere for it to round. So a question like that, where you have to really think about like what do we mean by rounding, and a lot of students are going to want to round that 72 to something. There's nowhere for it to round. It's already where it needs to go. This process probably makes a little bit more sense if we look at it on a number line. And this way we can kind of see all the marks and kind of see where these things line up and the distances a little bit more proportionally. So if I were to take my 72, so here's my 70, here's my 80, the 70 looks kind of sad. Let me fix that. So here's my 70. So here's 75. 1, 2, 3, 4, 6, 7, 8, 9. So here's my 72. And we can see if we're rounding to the nearest 10. So we're rounding to the nearest 10. Then that lets me know the distance between these endpoints. These are a distance of 10 apart. And so we know that we're going to be looking at this window of 10. And it also lets me know that this number here is going to be a multiple of that 10. And so we want to find this interval that 72 is on, where they're 10 apart and they're multiples of 10. So for some students, it might be worth having this conversation about, well, why aren't we going to use 60 and 70? Or why aren't we going to use 80 and 90? Or why aren't we using 75 and 85 or 65 and 75? I mean, there's an understood process as to what this is, but if it's been a while since you've explained this idea of rounding, it might be worth your time to really think about what this process is like and how you would explain it to somebody who's never seen this before. We see this distance here is 2, and this distance is 8, just like we saw on the previous slide. And so since this is closer, then it rounds to that 70. It is the closest value of these two endpoints. And so once students are able to construct this little number line and know what these endpoints are, and they're able to locate that number, then the rounding process is pretty simple and pretty direct. Now, we could do the same thing with a little bit more complicated numbers. So let's take 374. So 374, again, we would want to know like what we're rounding to, which place are we rounding to. So we could do it to the nearest 10, but it would be a lot like the previous problem. We could also round it to the nearest 100. And so now we're going to the nearest 100. And so now we know that we want multiples of 100. We know, and so because they're multiples of 100, this distance will be 100. And so 374 is going to be between 300 and 400. And so here's my 350. 1, 2, 3, 4. 1, 2, 3, 4. And so now we have to think about where this number is going to be. And so what I like about this problem, different from the previous problem, is this 72, we can find out exactly where it is. But this 374, we're probably not going to know exactly where it is, but we have a pretty good idea. We know this is 350. We know this is 360. We know this is 370. So it's ballpark around there. Now, if we have it a little bit high or a little bit low, it shouldn't change anything because it should still be pretty obvious that it's closer to the 400. So again, we talked earlier about this idea of being more concrete or more abstract. This is a more concrete problem here. So this one is more concrete because we can see exactly where that number is. Now, once we start moving to something like this, where we don't know exactly where it is, this becomes more of an abstraction. Because now we're asking students to sort of understand how this number line works. We're asking them to think a little bit more implicitly about distance. We're asking them to do a little bit more in their mind and a little bit less on the page. And so we can see here that this rounds to 400. Cool. that's pretty much all I got to say about rounding. There's not that much to it other than thinking about models for it and thinking about ways you would explain this topic. I'm going to leave you with this problem. So 9.624, if we were to round that to the nearest ones place, the nearest tenths place, and students are going to struggle a little bit with tenths versus tens. So that's a very different problem, but tenths place, hundredths place. So how would you round that number to those three places? And then what is same and different if we were rounding negative 9.624 to the same place values, to the nearest ones, the nearest tenths, nearest hundredths? So how does that problem change? How is it the same and how is it different? So I'll leave you with that problem. And if we want to talk about that problem in class, then make sure you bring your questions about that problem. All right, thanks.